Okay. So in this section, in this chapter 5.1, we're going to start talking about polynomials, monomials, and so on. So first and foremost, a monomial is a number, a variable, or an expression that is the product of one or more things, right? A monomial is simplified when there are no powers of powers. Each variable appears only once. Fractions are in simplest form. No negative exponents. No roots of variables. So what are some examples of monomials? For example, 3x squared y is a monomial. Okay? 5a over b is a monomial. Okay? So do you notice there are no negative exponents, there are no roots of variables, there are no addition or subtraction of things. It's just several things multiplied or divided by each other. Okay? And then another example would be, let's say, negative 3cd over a squared b, right? Again, there is a negative out front only because the monomial itself is negative, but it's not being added or subtracted to from something else. Okay? All right, a polynomial is a monomial or the sum of monomials. So for example, if I had 5x plus 8y, that's a polynomial. Do you see how it's got one monomial, two monomial, right? More than one monomial. Negative 3x squared plus 2x minus 4, that's a polynomial. Okay? Correct. More than one term. Now, x squared y plus, 3z minus 4xz. Okay, that's also a polynomial. All right. The degree of a monomial is the sum of the degrees of each variable. Okay? So for example, if I have 3x to the 4, the degree is 4. Now if I have negative 7x squared y to the 3, now the degree is how much? 5, because you add up all of the exponents. Okay? The degree of a polynomial is the degree of the monomial with the greatest degree. So if I have 5x squared plus 3x minus 4, what's the degree? 2. Now if I have 10x squared y minus 5x cubed y to the 7, to the 6, plus 4xy to the 5, okay? What would be the degree of this polynomial? So let's see. What's the degree here of this term? Not 2. 3. How about here? 9. And here? 4 and 1? 6. 5 and 1 is 6. So the degree is 9, right? So here, 2 and 1 will make 3. 3 and 6 will make 9. 5 and 1 will make 6. So the degree is 9. Because if you just have like a variable without an exponent, there's an imaginary 1 there that we just don't write. 18 because you add them. It's the sum, not the product. Right? So here, for example, you have x squared y cubed. You add the 2 and the 3 to get a 5. That's the degree. So here, 2, 3 plus 6 is 9. Yeah? So you only add together those two? No. So with each one, okay, so here we added the 2 and the 1, we got a 3. 3 and 6, you get a 9. 1 and 5, you get a 6. Now you just need to take the highest number. That would be the degree. The highest number. Yeah. Okay? Okay. Yeah, so it's the degree of the monomial with the greatest degree. Okay, so here, state whether each expression is a polynomial. If it is a polynomial, state the degree. So now, for it to be a polynomial, you cannot have any, you cannot have any variables as a denominator, right? So here, because you have a variable in the denominator, this is not a polynomial. Okay, you have a variable in denominator. All right. Here, take a look at this. No variables in the denominator. Look at the exponents of the variables. Okay, the exponents of the variables are all either 0 or positive integers. 1, 2, 3, 4, 5, and so on. That makes this a polynomial. Are there any square roots of variables like root x, root y? No. Is there an absolute value of a variable? Absolute value of x, absolute value of y? No. Is there a variable in the denominator? No. Are any of the exponents negative? No. That's what makes it a polynomial. So yes, this is a polynomial. Now let's check out the degree. What's the degree of this one? Somebody raise your hand if you know the degree of this one. Yeah. 6, because this is a 1, so it'd be 6. Okay, what? Oh, you meant of the whole thing? Yeah, of the whole thing, it is 7, because this has a degree of 7. This has a degree of how many? 2. The highest number is a 7, so this entire thing has a degree of 7. Okay? Okay. All right, so let's review some things about what to do with powers. Okay? Okay. All right, so if you have a product of powers, you add the exponent. So x to the a times x to the b, you add them. So for example, if I had x cubed times x to the 7, this is going to be x to the 3 plus 7, 10. Okay? You add the exponent if you're multiplying powers. If you're dividing powers, you divide the exponents. So for example, if I have x to the 9 divided by x to the 5, this is going to be x to the 9 minus 5, x to the 4. Okay? All right, you divide them. Any questions? I'm sorry, subtract them. You subtract them when you're dividing. I'm so sorry. You subtract them when you're dividing. Okay? Okay. X to the negative a, you cannot, okay, it's illegal to have a negative exponent. So you have to make it a positive exponent. What's the price to make it a positive exponent? You have to change its spot. So if it's upstairs, it's got to go downstairs. If it's downstairs, it's got to go upstairs, right? So for example, if I have x to the negative 4 and I want to make it positive, x to the negative 4 is a numerator. I have to make it into a denominator, 1 over x to the power of positive 4. Okay? Let's do another example. Suppose I have like 3 over x to the negative 2. Now, okay, I can't have a negative exponent, but this time it's in the denominator. It's got to move up to the numerator. So this becomes 3x to the positive 2, right? From the denominator, it's got to move up to the numerator. So think of it as upstairs, downstairs, okay? If you have a negative exponent, you can make it positive. You just have to change the story that it's on. Okay, from the first story it goes to the second, from the second it goes to the first. Does that make sense? You guys are saying yes, but I'm not. Are you guys okay with that? Yes, no? Okay. Now, look at this one. This is a power of a power. I have x to the power of a to the power of b. In this case, they multiply. So if I have x to the power of 3 squared, now I multiply them, it'll be x to the power of 6. Do you see the difference between the first one and this one? Okay. Now, if you have two things in parentheses with an exponent on top, you basically distribute and you give each one the same exponent. So for example, if I have x times y to the power of 3, this will be x cubed, y cubed. Everybody gets the same exponent. You don't add them? No, just give one to each. If you're dividing, it's the same situation. So if I have x over y to the power of 4, x to the 4 over y to the 4, right? Everybody gets a 4. Okay? Okay. Now, let's talk about what if you have a negative. Okay? If you have a negative exponent, first of all, it's illegal to have a negative exponent. You can make that a positive, but inside, whatever's upstairs has to go downstairs, whatever's downstairs has to go upstairs. So that means you flip this, right? You flip this, it becomes positive a. Yeah, when you have a fraction with a negative exponent, you flip the fraction, the negative goes away, then you can distribute as before. Cool? Cool. Okay, 0 power, what's anything to the power of 0? Oh, no. 1. Anything to the power of 0 is 1. Okay, 5 to the 0, 1. Table to the 0, 1. Okay? All right. So, what do you do when you're asked to simplify expressions? You have to rewrite the expression. You cannot have any parentheses, no common terms, no negative exponents. That's like legit illegal to have a negative exponent. Okay? All right, so let's do this one. So here I have xy squared times all of this. Okay? So basically, if you're just multiplying all of these, then they're all being multiplied. One thing is you can just get rid of the parentheses, right? X times y squared times x to the 4 times y to the 3. All of these are being multiplied. Now, let's see what this gets us. When you are done simplifying, each variable is only allowed to show up once. So here, I'll get you in a minute, Sunny. Here I have an x here and an x here. The x's show up twice. I need to combine them into one x. Now, are those two x's being multiplied or divided? Multiplied. When you multiply them, what do you do to the exponents? Add them. So this has an exponent of 1 and an exponent of 4. Together, it becomes 5. The y, you do the same thing. I have an exponent of 2 and a 3. I add them, and I get a 5. And now it's simplified. Okay, did you have a question or a comment? Okay. All right. So, do you see that? Okay. No negative exponents. Each variable shows up once, and we're done. Okay. You add the exponents because they were being multiplied. The like ones? The like ones. You can't add an exponent of an x to an exponent of a y. Okay, here, same situation. Now look, instead of like rewriting it without the parentheses, I'm going to skip that step so we don't have as much writing, and we're just going to go through. Okay, so first of all, now I also have some coefficients. So let's take care of the coefficients first. -3 times 4, that will be -12. Because all of these are being multiplied to each other. One thing times another thing. Those are exponents, yeah. Okay, here. Okay, so we have an a. What are the exponents of the a's? I have a 4 and a 1. They're being multiplied. I need to add them, so it's a 5. Okay. Now for the b. So take a look. For the b, you have to be super organized. I have a 2 and I have a 6. They're being multiplied. I need to add them to an 8. And then I have a c. Are there any other c's? No. And I have a y to the 7. Are there any other y's? No. So you just leave them like that. Okay? Okay. One at a time. Yeah.
Do you write the degree or does it have to like say?
It doesn't ask for it. Yeah, Sam. Okay, here. Okay, now I have an exponent outside. So remember PEMDAS, right? Parentheses, exponents, and so on and so on. So exponents have precedence. So I have to distribute this here and here. What this turns into is the following. 2 to the power of 4. And then a cubed to the power of 4. Do you see that? Everything gets an exponent. 2 to the power of 4, a cubed to the power of 4. Okay? So another way to look at it is this. In here, you have a 2 and you have an a cubed to the power of 4. So each one of these now gets an exponent to the power of 4. Now, 2 to the power of 4, you're going to do this on your calculators, right? 2 to the power of 4, 16. Times a to the power of, so here, do I add or multiply the exponents? Multiply them. So it becomes 12. Okay? Okay, here. I have a 2 out here. So look, what do I have in here? I have a half. I have a c. I have a d cubed. So I have half squared c squared, right? And then I have a d cubed squared. Okay, so what happens to the 1/2 squared? The 2 goes to the 1 and the 2 goes to the 2. So like this, 1 squared over 2 squared. Yes. Yeah, I'm going to simplify in the next step. So c squared times d to the what? 5 or 6? 6. So finally, this will be 1 over 4 c squared d to the 6.
Do you have to do 1 squared over 2 squared? Can you just skip the...
No, you can skip to 1 over 4. All right, next one. Yep.
For C, I don't know like why. Oh, I see. Because the 3 is part of the A.
Yep. Okay, so here, take a look. First, I have these exponents to take care of. Okay, so this is going to be -5 cubed m squared cubed n cubed times 3 squared m to the 4 squared n to the 5 squared. Do you see that? I really haven't done any math yet. I just distributed the exponents to everybody here. Okay, look at the negative. Look at where the negative is. I have to put it inside the parentheses. So now, -5 to the power of 3. Oh, what's that? We need to put this in the calculator, right? But please use, it's okay, it's fine. But please use parentheses, so -125. Okay, what do we get here? M to the what? 6. N cubed times, what's 3 squared? 9. What do I get here? M to the what? M to the 8. And what about here? N to the what? 10. Now I need to combine. Okay, can somebody tell us what the numbers will be? -125 times 9. How much will that be? Come on. What do you guys think? Where are your calculators? No, we're not guessing. Put it in your calculator. Is it 125?
Yeah, I got 1,000.
Or yes. Good. Okay, so what about the M's? How many M's? Oh, negative, thank you. Oh. M to the 14 and N to the 13. Okay? Okay? So 6 and 8, we have to add them. Okay. Okay. Oh, wow, look at this one. We've got parentheses after parentheses after. So we have to start inside and work outwards. So this was N to the 3, and then I had an N to the 10, and I have to add the exponents. Yeah. So we multiplied the 125 and the 9, remember? Yeah? Okay. Can everybody please have your calculators out and ready to go? Okay, so first we're going to distribute the 3. So we're going to have negative 3 cubed, a cubed, b squared cubed, still with a 2 outside. Okay, so what's this going to be? Right here. Right here. Okay, all right. So what is the negative 3 going to turn into? Negative 3 cubed. Negative 27. Okay. Then I have an a cubed. And here, look, b squared to the power of 3. I multiply those exponents, so it's b to the 6. And I still have a 2 out here. Now we're going to distribute the 2. So it's going to be negative 27 squared, a cubed squared, b to the 6 squared. Okay, so go ahead and plug the negative 27 squared into your calculators, please. What do you guys think? So it's 729, but is it going to be positive or negative? It's going to be positive because the negative is inside the parentheses. You've got to include those parentheses. And then, okay, so Maddie, what's going to be the exponent for the A's? 6, okay? Asher, what's going to be the exponent of the B's? 12. All right, so that's your final answer. Okay, yes, Kaden. You mean the outside 2 and the outside? I like to work inside and then go out. Okay, that's the more correct way to do it. Okay, so let's take a look here. Here we have a fraction, right? 8 and 4, those are going to simplify to 2. Oh. 729. Okay, let's go to G first. So we're dividing these. It means we have to subtract the exponents. So it's going to be x to the power of 8 minus 5 x cubed. And of course, you don't have to write this step with the red. You could just go straight to the final answer. Here, okay, I have 8 over 4. That gives me a 2. Now, the y's, I have 7 minus 6. That'll be a 1, which you don't have to write it. The z's, I have a 6 minus a 5. That's also a 1. Remember, you always have to do top minus bottom, not necessarily big minus small. No, top minus bottom. Okay, so this will be 2yz. You don't have to write the ones? No. No. It's just not cool anymore. We're in the big leagues now, Sonny. Okay. It's like if you were to write like X, would you ever write 1x? That's just so silly. Huh? Yeah. Yeah. So if you want in the intermediate step, like write a 1, and then final step, just ignore all the ones. Okay? Yeah. We got to, I mean, you know what I mean. Yeah. Okay. All right. Here, 14 and 21. Does that simplify evenly? No. Right, but it doesn't simplify evenly. So what happens is you divide by 7, you get a 2 and a 3. Okay. The A's, you write it in the top. Okay. 5 minus 3. And then the B, you write it in the top, 4 minus 4. So let's simplify this. I have a 2 on top, A to the what? 2. And B to the 0, all over 3. And what's B to the 0? 1. So you ignore it. So it becomes 2A squared over 3. Yes, because, so here's what we do. When you're subtracting that, listen guys, when you're going to subtract the exponent, always put the variable on top, subtract it. 5 minus 3, I happen to get a positive 2, it stays where it is. Now if I had gotten a negative 2, I would have had to move it. Anything to the 0 is a 1, so you could just get rid of it.
Wait, so if b times 1,
but this isn't b to the 1, this is b to the 0, which is 1. Okay? Yeah.
So if like whatever the reason I was to get like 5, like where we did 5 minus 3, if whatever it was equaled 0, instead of putting it on the top, I would put that whole with the variable and the exponent on the bottom.
Yeah, if it was a negative number. We're going to do a lot more. Let's see. I promise I have like variations of everything. 2 and the 3. Can we do anything about this? No, just copy them over. Just transfer them. Okay. So the x's, guys, take a look. This is where it really gets to count. Hang on. You have to go highest, top minus bottom. So 2 minus, what's the exponent on the bottom? Negative 4. Do you see the repetition of the negatives there? That is so important. Okay. Y top minus bottom. Do you see that? Do you see how careful we have to be with those negatives? Yeah, this is why in the beginning I kind of forced you guys to do some things without a calculator, because you have to have a little bit of number sense. Yeah. Okay, so now let's take a look. In the denominator, I still have the 3. Here I have a 2. X to the 2 minus 4, 6. Y to the how much? Negative 8. Okay, now we have a problem because you can't have negative exponents, so it's got to go downstairs. It's got to change stories. Yeah.
why did you switch the negative 4? Why did you have to do that? Or no, you get a positive number. Yeah, but let's say you do get a positive.
But so let's not, okay, so why don't we take them case by case, Sunny? Because if we go into the what if, then we can be here until tomorrow. And, you know, we just got into 2024. We're not going to be here until 2025. Okay, so look at this. Do we have an issue with exponents here? No. Here? No. Here? The y is the only person with a negative exponent. The y is the only person that moves downstairs. So only y moves downstairs, and it becomes y to the positive 8. Okay? Don't you go touching other people who don't have any issues. Okay? All right. Okay. Even in my honors classes, people struggle with this. So like this is like an across the board. This is why I make such a big deal out of this. Don't be touching people with no negative exponents, okay? All right.
And there's like no process to moving it, you just
Correct. And we didn't move it. We subtracted it though. Okay. Had you moved it, it would have been x squared times x to the 4. It would still have been x to the 6. And okay, it would have been the same. Why don't we look at that later? Okay. All right. We're going to distribute the 2. Here's what we're going to do. we're going to do, we're going to try to skip a step. Instead of rewriting it, just do it in one shot. So 6 squared will be how much? 36. Now, w to the 5 squared, I multiply, and it'll be w to the 10. 7 squared will be 49. P cubed squared, multiply the exponents, I get a 6. And it'll be s to the how much? 12. Is there anything here that can simplify further? Do the 36 and the 49 simplify further? No. Any negative exponents? We're done. Okay? Okay. Whew. All right. Let's do this one. 4 cubed. This is a calculator one, right? 4 cubed. How much would that be? Somebody tell me. Is it 64? Mm-hmm. Okay. All right. I'm going to ask you guys one by one this, okay? Marley, what would be the exponent of the f? 9. 4 times 4 is 16. Times 4, 64. Good. Okay. So then, Sienna, what's the exponent of the g? 3. 3. G cubed. Right. Okay. All right, Liam, what would be the exponent of the, okay, so it'll be 3 cubed here, which is 27. And Liam, what would be the exponent of the h?
3 cubed.
It's too many numbers. So Liam, what about that exponent for the h? 18, okay? Anything that can be simplified here? No. Okay. Fantastic. Okay. So here. All right. We have an x cubed, y to the negative 5, x to the negative 8. Okay, so many things here. Negative exponents everywhere. And then we are only allowed to have a variable up here one time. Here I have an x and an x. So what I have to do is combine. Do I add or subtract the exponents for the x's?
No,
Add, so it'll be 3 plus negative 8, which is 3 minus 8. Y to the negative 5. So, x to the negative 5 and y to the negative 5. Okay. Now, both of these have negative exponents. Both of them have to move downstairs individually, though. So, x to the 5 moves downstairs and becomes positive. Y moves downstairs, becomes positive. Nothing is left on top, so what do I put as a filler? A 1. Okay? Okay. Ooh, this one's fun. Okay. The negative 15 and the 5, what happens? How much? Negative 3. Okay, what happens to the w? It's a 1, so ignore it. Now I got a u. U minus 1 minus 3. Okay, so it's over 1 right now, right? So what is this? Negative 3, u to the what? Just 4? Negative 4. Okay, so over 1. So what happens now with this u? You want to move it down. Does the negative 3 also move down? No, because it doesn't have a negative exponent. Negative 3 stays on top. U to the 4 moves down, and that's it. So look at this. In the denominator, when I moved this up to subtract, there was nothing left in the denominator, so I put a 1 as a filler. But once the other one moves down, it moves down. Yeah. Yeah. Okay, let's quickly do these. Okay, should we distribute the negative 2? Yeah, let's distribute the negative 2. So I have x to the what? Negative 2 times negative 2, positive 4. Y to the negative 10. X to the negative 8. Y to the 6. Right? I'm multiplying everything with a negative 2. So I get here. Okay. X to the power of 4 minus negative 8. Y to the power of negative 10 minus 6. So 4 minus 8, x to the 12. Y to the how much? Negative 16. Okay. Now, x is fine. Y is not. X stays, y moves. So x stays, y moves, and that's it. Okay? All right, let's do some of the bottom ones, for example, 2. These are just review, actually. There is nothing new here. All of this you guys had done in the previous chapters, okay? The new stuff was all the stuff that we already did. Huh? Yeah, we're going to do like a little bit of each. Let's do A first. Look at this negative. I got to distribute that negative. So here I get negative x squared minus 3x plus 4 minus x squared minus 2x plus 5. Okay. Negative x squared, negative how many x squared? Negative 2x squared. Minus 3x minus 2x, negative 5x. Plus 4 plus 5 plus 9. How cute is that? All right, let's move down to C. Distribute. Okay. Even at this age, I like to do those arcs so I know not to forget something. So 4 over 3 x squared times 6x squared plus 4 over 3x squared times 9x. Right? You have to give one to everybody. I'm just writing it out. Okay? 4 over 3 x squared times 12. Okay? Actually, why don't we stop here today?